All right, good morning. We're going to pretty much finish chapter 2 today. We did section 1 last time, increasing, decreasing functions. Today we're going to talk about the algebra of functions. We're going to do symmetry and transformations, and I gave you handouts for those. So, I mean, you take a picture of this so we can, you have to write it all down. This is day 6. Chapter 2. Section 2. Algebra of functions and the difference quotient. Section 4, symmetry. And odd versus even functions. And then section 5. Transformations. And reflections. So this is what we're going to do today. It seems like a lot, but it's really not. I mean, the 2 sheets I gave y'all will help you with the last 2, make it much easier. Okay, to begin with. Section 2. The reason we're doing section 3 here is because that's composite functions, and that's going to be at the beginning of chapter 5. So when we say algebra of functions, what we mean is you can add them together. You can subtract them, you can multiply them, and you can divide them. Not just equations, but you can do the functions themselves. For example, if I had a function defined as x plus 1 and another one defined as 3x, we can do 4 things with them. Well, the first thing, we can add 2 functions together. What this really means is we can either add the 2 functions together and then put in our value x, or we can put the values x in each one of them and then add the answers together. For example, what this means here is we can combine the 2 functions. So the function f is x plus 1. There's the plus sign. And g is 3x. So let's say I want it at 2. I'm going to say for all of these, I'm going to say x equals 2 for all of these. So on the left-hand side, we can combine like terms first. X plus 3x is 4x plus 1. So this is my f plus g. Now I'm going to plug in this for x. This doesn't mean multiplication. This is still the f of x notation. So anywhere I see an x, I put a 2. 4 times 2 is 8, plus 1 is 9. It may be, if we just take a picture of it real quick, it may be easier for this just to catch up. We just started about 3 minutes ago, so you're not too far behind. Yep. All right, so that's the addition of the algebra part. Now let's look at the subtraction of the two functions. Let's do f minus g of x. We can subtract the two functions before we put the number in. What this really means is we can either subtract the two functions and then put the value in, or put the values in and then subtract the answers. Again, we're saying for all of these that x equals 2. The function f is x plus 1. There's the minus sign. Now, whenever you have a minus sign, whatever is behind it, put it in parentheses. Because if it's an equation, if you don't put it in parentheses, only the first term gets changed. Everything else stays the same. So, and we're going to say we want it. So we just substituted those, and there's my value of x. Follow the order of operations. Can you do anything inside this parenthesis? No, since it's only one term. So we don't need that parenthesis. So it becomes a negative 3x. Combine like terms. X minus 3x, since 3 is bigger, the answer is negative. 3 minus 1 is 2x. Remember, these are still function notations. So now anywhere I see an x, I put a 2. Negative 2 times 2 plus 1. Negative times positive is negative. 2 times 2 is 4. Negative 4 is bigger than 1, so the answer is negative. 4 minus 1 is 3. So far, so good? So that's what the inside, the first part means. Now let's look at what happens if we plug in the values first. So in this case, it'd be, what would f of 2 plus g of 2? So let's see what f of 2 would equal. Anywhere I see an x, I put a 2. So 2 plus 1 equals 3. So f of 2 equals 3. What does g of 2 mean? Three times 2, which is 6, right? So f of 2 is 3. G of 2 is 6. 3 plus 6 is 9. So they equal. As you can see, yeah, the right side's a lot faster. But worst case scenario, if we had bigger equations, it may be easier doing this, because if you have two long equations and you try to put these in there, the numbers in there, then you have to do two long. But if you combine them, it could shrink them up, make them even smaller, so it'd be a lot faster. So is you have the choice of what to do. So here we have f of 2 minus g of 2. F of 2 is 3. G of 2 is 6. 3 minus 6 is negative 3. So they both equal negative 3, and that's the answer. Okay, now let's do with multiplication and division. All multiplication really means is you can take the first function, f of x, and multiply it by g of x. Or we can take the fractions and divide each one separately. This is where doing them separately may come in helpful. So in this first one, since we're multiplying them, f of g is x plus 1, and g is 3x, and we're multiplying them. So we have to get rid of the parentheses inside here. We can't do anything in here. We can't do anything in here, so we multiply. X times 3x is 3x squared. Positive times positive is positive. 1 times 3x is 3x. So we're saying now, remember, we're saying that x equals 2. So anywhere I see an x, I plug a 2. 3 times 2 squared. 3 times 2. Excuse me. Order of operations, you have to do the 2 squared first. So it's 3. 2 squared is 4. 3 times 4 is 12. 3 times 2 is 6. 12 plus 6 is 18. Pretty straightforward enough. On the right-hand side, we have f of 2 times g of 2. F of 2, well, is, well, we know that that's 3. And g of 2, we know that that's 6. So we have 3 times 6, which is 18. And they equal. Yeah, because on the left-hand side, we will obviously make it bigger because we're combining two polynomials. On the right-hand side, it's a lot easier. We're multiplying numbers. So in this case, the right-hand side is much easier than the left. Now, on this last one, the left side could be easier if you can cancel some terms out. But if there's a plus or minus, this has to stay as one equation. You can't cancel the x's. If something's going to cancel, it has to be out in front. It has to be multiplied together. You can't, addition and subtraction, you can't cancel those. So since nothing can simplify there, we're going to do it when x is 2. So anywhere we see an x, we put a 2. 2 plus 1, 3 times 2. Three over 6, and you can simplify, so it makes it 1/2. On the right-hand side, we have f of 2 divided by g of 2. F of 2 is 3, g of 2 is 6. So they equal same thing. So you can do whatever you want, whatever is easier for you there. All right, let's look at a more difficult example. I don't say more difficult, but it throws it'll throw you for a trick. So f of x equals 3x plus 1. G of x is the square root of x plus 1. And we're going to look at it when x equals 3. So we're going to do these 6. Remember, f of x is 3x plus 1, g of x is square root or radical x plus 1. So in the first one, what are we going to do?
We gotta write it down first, so 3x plus 1 plus square root of x plus 1.
Can you go any further?
Oh, yeah, reword the x is
You can do what?
reword the x.
Mm-mm.
You multiply by x.
Because remember, this is f of x. There's your plus, and there's your g of x. Nothing you can do. Because you can't combine a radical with anybody else. So that's as far as you can go. So when we do this one now, well, what's f of 3 going to be? Yeah, so it's 3 times 3 plus 1 is 10. And g of 3? 3 plus 1 equals 4, which makes it 2. So it's actually going to be much easier if we do this. 10 plus 2 equals 12. Well, let's look at if we did this other way. In other words, what this way would be if we did it f plus g at 3. So anywhere C in x, put a 3. Nine plus 1, square root of 4. Square root of 4 is 2. So it equals 12. So they equal the same thing. All right, let's look at the minus one. Can you tell me off the bat what it's going to be? Yeah, because we have f of 3 minus g of 3, which is 10 minus 2, which is 8. And last, the multiplication one? Very good. 10 times 2 is 20. Very good. The division one? And divided by 2 is 5. How about this last one? Yeah, because it's g of 3 times g of 3. 2 times 2, which is 4. Okay, so that's just getting numbers. We also talked about domains and ranges, but here we're talking about domains only. What is the domain for all four of those, or for all four of the algebras? F plus g of x, f minus g of x, f times g of x, and f divided by g of x. First, tell me the domain of f and g, and then the domain of those guys. So what's the domain of f of x? What does the domain deal with? Only the x values. There are 3 types: positive, negatives, and zeros. Are there any restrictions? Are there any restrictions on what x you could put in there? No, because what kind of equation is this? We did this in chapter 1. Think of y equals mx plus b. Notice the x. It doesn't have any power or anything special about it. Yeah, so it's a linear equation. This is a linear. Again, I need you guys to memorize the library of functions. You're going to see when we do the transformations, it's going to make it much easier for you if you memorize those ASAP. So this is a linear equation. So the domain is from negative infinity to positive infinity. G of x is x plus 1. What's its domain? Nope. What kind of equation is that? What does the graph look like? Nope. That's this one. That's linear. We have, this is a square root, a radical. So what's the domain? In your picture, what's the smallest it can be?
0 to 100.
Yeah, because the graph looks like this. You cannot put negatives inside square roots. So this one is only 0 to infinity. So the domain of this one the domain of that one is what? It can't be negative infinity. We just said we can't use negatives for the radical. For this part, we can't use negatives. Let's see if you can get this one. What's the domain here? Very good. What's the domain in the third one? Why? Yeah, because you still have a square root there. Okay, this one is going to throw you for a loop. Because I know what you're going to say, and you're partly right. You're going to say what? But there's one extra thing in here. Actually, let me go back a little bit. All four of these are wrong. You're off just by a little bit. Because remember, this graph looks like this of this function. You cannot have a 0 in there, right? That's just an x. But we have an x plus 1 here. So whenever you have an equation inside the radical, take the equation inside the radical, set it equal to 1, and solve for x. That's the smallest you can have. -1 to infinity, -1 to infinity. Because this equation, the square root of x plus 1, is not the same as square root of x. This has got an x plus 1. But in the fourth one, there's another thing we can't use. Okay, so this is a general one. What's another rule about fractions we can't have? No, negative. You can always divide by positive. Okay, it's right between which you guys are shooting at. What's between negative and positive? 0. You can't divide by 0. It's undefined. So since when x equals -1, it makes the bottom equal 0. Here, the bottom cannot equal 0. So when does the bottom equal 0? When x equals -1. So we cannot use a -1. So this one is like that. It's not a bracket anymore. It's now a parenthesis. Since we cannot use -1. But the rest of these are okay, but it's just when it's on the bottom, it changes. So basically, you guys are right. Whenever you look for the domain of functions, first find the individual domain of each of the functions. Whatever the smallest one is, that's your domain of your answer. So the domain, the smallest domain is the domain of your answer. All right, so that does it for section 2. Oh, no, it doesn't. It doesn't. I forgot we have one more thing. We have what's called the difference quotient. In chapter 1, we learned the formula for a slope. y2 minus y1, x2 minus x1. That's a slope of what? Slope of a line. Very good. This is a slope of a line. But what about a slope of a curve? This one, the difference quotient, finds the slope of a curve at any point x. On its domain. Let's see what this means. Here in chapter 1, we had 2 points. We connected the dots and we found the slope. Ruler here. But yeah, so this equal x1, y1, x2, y2, the first point and the second point. Same thing here. So this one corresponds to y1 and this one corresponds to y2. If we drew a line to find the slope between those 2 points, oops, we found the slope of that line. Is that the slope of the curve? No. This is what is called a secant line. A secant line crosses a curve at 2 points. But that's not going to help us. We want to know what the slope is of a curve at any point. Let's say we want to know what the slope is at that point. How do we figure this out? Okay, we're still going to use a line because the line, we still use the line to figure out the slope. But we have this point and this point. We have to get this point to this point. We call the distance between these two, we call that h. Because to find the slope of a curve at any point, we can only have one point. We have to somehow get rid of x2. We do that. If we move x2 closer to x1, eventually they become the same slope, the same equation. And what happens to the line? It eventually turns, and eventually we get that. So if we know the slope of this line, then we know the slope of the curve at that point. This is called a tangent line. The tangent line only touches a curve at one point. So far, so good. Let's look at how these guys work. So let's say x1 is 3. And h is 5. So what do you think the value for x2 is? Remember, h is the distance between them. 8. You start off at 3, you add 5, you get to 8. So x1 plus h equals x2. So as h becomes smaller, so now we have this point here. Let's say it is 5. So what's h now? What's our new h between these two? 2. So you see, as h is getting smaller, these values get closer, closer, closer. These points get closer. So eventually we get to that. As long as h goes to 0, we get to this point. We get a tangent line. So we know the relationship between x1 and x2 is this formula. But what is h? How would you, if I ask you to find h, how would you find h? Close. Yes. x2 because it's the bigger minus the smaller. So there's a relationship between x1 and x2 again. Remember, with the difference quotient, we can have only one point. That's this point. All right. So let's refresh. What's another way of writing y1 as a function? It's a function of x1. Remember that y is the same thing as f of x. So y1 is the same thing as f of x1. y2 equals f of x2, right? So far, so good? Good. Because now we're going to take the step from linear equations to curves to find the slopes. So we had y1 or y2 minus y1 over x2 minus x1. This one is f of x2 minus f of x1 over x2 minus x1. But we still have 2 points. We can only deal with one. So what is x2? What's another way of writing x2? X2 is x1 plus h. So this first one becomes x1 plus h minus f of x1. And what does x2 minus x1 equal? Very good. It equals h. So there you have it. We only have 1 point, x1. x1, since that's f of x1, this is y2. So our formula is f of x plus h minus f of x divided by h. This is our difference quotient. The slope of a curve at any point. Now, let's learn how to use it. Got it? Right. So here's an example. Let's use the difference quotient. Find m using the difference quotient. For the function f of x equals 3x plus 2. Remember, the difference quotient is f of x plus h minus f of x all over h. Here are the steps. One, find f of x plus h. Because we have f of x. We have this part. H is just a letter we put down there. The only thing we have to do is find this one. You do this by placing a plus h. Let's say th. After each x in the equation. F of x. So here's an x. Here's our first x. So what do? Put a plus h behind it. Here's another x. So I've put a plus h behind that. Oops, it's 2. plug f of x plus h and f of x into the difference quotient. So this equals the slope. The formula is x plus h minus f of x. So what is f of x plus h? This whole big thing. 3x plus h plus 2. The minus sign. Place the f of x inside parentheses. Whenever you have a minus sign in front of a function, put a parenthesis before you put anything else in there. So now we plug in the f of x, which is 3x plus 2. All over h. And then simplify. So get rid of the parentheses. 3 times x is 3x. Positive times positive is a positive. 3 times h is 3h plus 2. This minus sign changes everybody's sign inside the second equation. So that positive 3x becomes a negative 3x. That positive 2 becomes a negative 2 over h. Right. If it was a negative 3x minus 2x, it would be a positive 3x plus 2. See, and that's the reason we put the parentheses. Because if you didn't put the parentheses, then you'd have a negative 3x plus 2, which would have been totally wrong. Now combine like terms. Okay, here's a hint. When you get, after you do this minus sign, everything after this, everything here should cancel. This 3x cancel with that 3x. Negative 2 cancel with the positive 2. So we have 3h over h. H is cancel, and the slope is 3. We knew that was supposed to be the answer because this is a linear equation, mx plus b. The slope is 3. This is just, I'm using this just to show you a simple, it works. This is the way it works. Okay, so let's take it a notch up. Two x. Let's just try, forget the 2. Let's do x squared plus 3x plus 2. That's your f of x. F of x equals x squared plus 3x plus 2. Find the difference quotient. Which is actually your slope. You guys want to try this yourself first? Okay. Say it. I'm sorry I did that, but I only, the first one wasn't too hard, I hope. So the first thing we have to do, remember, is find f of x plus h. Anywhere you see an x, put a plus h around it. And notice I always put them inside parentheses. F of x plus h minus f of x over h. F of x plus h is this whole long equation. Plus 3x plus h plus 2. Here's the minus sign. And remember, whatever's after the minus goes inside the parentheses. X squared plus 3x plus 2. Now, this part here is going to give us some trouble because what it means, x plus h squared really means x plus h times x plus h. And we haven't covered this yet, but yet they throw it in chapter 2. So what this means is everything in the first parenthesis has to multiply to everything in the second parenthesis. So I'll start with first. X times x is x squared. Very good. Positive times positive is positive. X times h. No, x times h is xh. Because remember, this first one has to multiply both of those. Now, since that one's done, the second one, you have a positive h times positive x is positive xh again. Xh and hx is the same thing. It's commutativity. And then positive times positive. H times h is h squared. Combine like terms, you have x squared plus 2xh plus h squared. And it's always going to be the case. Whenever you have something plus something squared, it's always going to be the first term squared and the last term squared. And the middle, it's 2 times both of those. So now, this is what goes in this first spot. So x plus h squared becomes x squared plus 2xh plus h squared. Then you have to distribute the second one, which is positive 3 times x is positive 3x. Positive times positive is positive. 3 times h is 3h plus 2. This negative sign changes all the signs inside the parentheses, so it becomes negative x squared, becomes negative 3x, negative 2. Remember, everything after the minus sign, this negative 2 cancels the positive 2. The negative 3x cancels positive 3x. The negative x squared, positive x squared. Two xh plus h squared plus 3h. That's what we have left. And you see, it explodes real quick, then it shrinks real fast as well. Now, each of the terms on the numerator all have one h in common. So I take out the h of the first one, I have 2x. I take out one of those h's, so I have h. Take out that one. The h's cancel. That's not really your slope because there's still an h in there. Remember, what does h represent? The distance between x1 and x2. So as h goes to 0, our slope becomes this. That's the slope of our curve at any point x you give me. So if I said find, actually, it may ask you find the equation of the line tangent to the curve. So first thing you do is find the slope. If the point is, let's say 1, 2, we first have to find the slope. So we plug in x. So the slope we know is 5. The slope at this point is 5. 5 over 1. And then from there, we find the equation of a line. Because we're looking for the equation of the tangent line. Remember how we did that in chapter 1? We have a point and a slope. This is x1, this is y1, that's m. So we have y minus 2 equals 5x minus 1. Five x minus 5. Add 2. So we have 5x minus 3. That's the equation of the line tangent to the curve at this point. Yeah, so what I would do, what the question would do is find the equation of the line tangent to the curve f of x equals x squared plus whatever at this point. So you first find the slope, then at that point find the equation of the line. So this is where this chapter and chapter 1 come together. It's just a very long way around it. Yeah, once you see it, it makes sense. But yeah, it's, and what upsets me is a lot of times, because we haven't talked about this stuff here, the foiling part, and yet they do it in chapter 2. I think they even have a question that looks like this. It's a cubic equation. So you would have to do this. Yeah, we first do this, and that would give us our x squared plus 2xh plus h squared. And we multiply it again with that. Well, it is a lot because we have 3 terms here and 2 terms. So when we multiply them, we'll have 6 terms. 3 times 2 is 6. And then we combine like terms if we can. So again, they threw that in there when we haven't talked about it yet. Yeah. Either chapter 3 or chapter 4. Yeah, yes. But anyway, this is how it would be asked you. So find the slope, find the equation of the line tangent. I'll show you how it would be written. Find the equation of the line tangent to the curve f of x equals x squared plus 3x plus 2 at the point 1, 2. That's the way it would have asked you the question. So your steps, find the difference quotient, because remember, the slope equals the difference quotient. When x equals 1, use that slope. The difference quotient is a slope. And the point to find the equation of the line. It's just a roundabout way that you have one extra thing to do, because the difference quotient is a lot of steps. So find the difference quotient, which is the slope. Plug in the value x being 1, that'll give you the slope. Take that slope and the point that's given and find the equation by using this equation. The DQ is difference quotient. Yeah, because remember, the difference quotient is the slope, is f of x plus h minus f of x over h. All these mean the same thing. At the x of the point you're given. It seems like we'll do another one. Now we're going to do one with a rational, with a fraction. Let's do 1 over x. No, let's do x plus 1. At 3, 0. Nabbit. No, it didn't good. I thought I wasn't taping. So remember the first step? So we have our function. Remember, f of x and y are the same thing. No, the first thing, in order to find DQ, what do we have to know first? Because we have the DQ function. What don't we have for this function? We don't have the f of x plus h. That's the first thing you have to find. Is f of x plus h. How do you find f of x plus h? Yeah, anywhere you see an x, put a plus h behind it. Okay, so we have everything we need now for our difference quotient. So we have f of x, which is x plus h. I'll do plus 1 minus f of x, which is 1 over x plus 1. Because this is f of x plus h minus f of x. So now what do we do? How? Well, since we have fractions up on top, we have to fix that first. We have to get a common denominator. So this is x plus h here. What the first one has that the second one doesn't have on the bottom is an x plus h. Plus 1. So it's an x plus h plus 1. Because this denominator is not the same as that one. And the second one has an x plus h by itself. So what's our common denominator? X plus h plus 1 times x plus 1. X plus 1. Because now we have a common denominator. So we look at the top. 1 times x plus 1 is x plus 1 minus 1 times x plus h plus 1. Follow me so far. This is this see how complex it gets? Because both of these denominators are different. And they're one equation. So that's this denominator is the whole thing. I need it up and down here. This one, I need it up and down here. So now they both have an x plus h plus 1 times x plus 1, x plus h plus 1 times x plus 1. They both have that in common. We have x plus h plus 1 times x plus 1. On the top, let's go ahead and simplify. You don't need the first parenthesis. The second one, we distribute the negative sign. There was a negative x, negative h, negative 1. On the top, the x's cancel, the 1's cancel, so we have a negative h on top. X plus h plus 1, x plus 1, all over h. So we have a fraction over a fraction. Take the top fraction and leave it alone. Multiplied by the flip of the bottom. Since they're multiplied, this h and this h cancel. So that leaves us negative 1 over x plus h plus 1, x plus 1. What's our next step? Well, we have an h down here. Remember we said as h goes to 0. Yeah, h goes 0. So what we have is our slope really is negative 1 x plus 1 times x plus 1. So that's our slope, negative 1 over x plus 1 squared. So what's our slope of our graph? Remember, I said at 3, 0 at that point. So x equals 3. Three plus 1 is 4. 4 squared is 16. So our slope is negative 1 over 16. Let's find the equation of the line. Tangent. Let's find the equation of the line tangent to the curve at that point. We have a point. We have a slope. Plug it inside here. So what's y1? 0. So we don't have anything there. You have negative 1 over 16. X minus x1. x1 is 3. So the equation of our line tangent to the curve, distribute that over, is negative 1 over 16 x. Negative times negative is a positive. 3 times 1 over 16 is 3 over 16. That's the equation of our line tangent to the curve at 3.0, or 3, 0. I know it's a lot of stuff I'm cramming down your head real quick. And that's right. So I'm glad I'm recording it so you can follow along later on. But the process itself starts off, it explodes. And then it gets smaller and smaller and smaller. But you have square roots, you have fractions, you have polynomials, x squares, x cubes, you have linear equations. Each one of them have their own rules that you have to follow. All that is the basic rules of algebra, of adding, subtracting, multiplying, dividing. Okay, that does it for section 2. You guys want to take a break or start the next section? Okay, let's just go ahead and keep on going then. I gave you all these sheets. Section 4 deals with symmetry. Chapter 2. I'll use another sheet for this one. Chapter 2, section 4. What does symmetry mean? Yeah. Mirror image. Same on both sides. Yeah. That's even better definition. Give me an example of something that's symmetric. Yeah. The square is very much symmetric, but a square is symmetric about where? About what? Let's say this is our X and Y axis. It's symmetric about the X axis. Because if I took the top part and folded it over, it looks the same. It's symmetric about the y-axis, because now if I rotate it across the y-axis, it looks the same. Because it's symmetric about the x-axis and the y-axis, it's symmetric about the origin. Whereas if I flip it across the origin, it looks identical. You notice I use the words about. Symmetric about the y-axis, about the x-axis. That just means the axis of rotation. What defines symmetry about the x-axis? Let's look at a picture. If it's symmetric about the x-axis, it's flipping this way. Let's look at a hyperbola. So how do we know it's symmetric about the x-axis? Mathematically. Yes, you described it in words, but now let's put it in math. You haven't proved it yet. When x is 1, what is y? Are you sure? If it's just 1, then it's not symmetric. Yes, for the same x, you have to have two y values that are the same number but different signs. For any x value, you have two y values with the same value or the number, but different signs. So what's the location of this first point on top? What's the location of the second one on the bottom? So you notice the x's are the same, the y values are the same number, but different signs. That means it's symmetric about the y or x-axis. Symmetric about the y-axis. This is the equation y equals x squared. When x is 2, what is y? When x is 2, what's y? 4. Because I squared. When x is negative 2, what is y? Right. So we have 2 comma 4 and negative 2 comma 4. For any positive and negative x value, same number, you get the same y value. So x is positive here, x is negative here, but the same number. In other words, what this thing says is if you put in an x value in the equation, work it out, you get a number. If you put the negative of that number and you get the same answer, we call that an even function. Even function is if you plug in a positive and negative x value same number, you get the same y value. So even functions are symmetric about the y-axis. Even functions are symmetric about the y-axis. Why can you not say that about the top one we just did? Why can't you say the same thing about this one? The word has to come with this word here. It's not a function. It fails the vertical line test. So we don't do anything with the x-axis. But it's symmetric about it. That's great, but it's not anything. So we can use the even function because it is a function. Symmetric about the origin. What function is this? What graph of what function is this? Oh, I know. You're supposed to put it in my memory. I know. No. This is the cube root function. Because it looks the same as the square root. It looks the same as a square root, but with a cube root, because that's an odd number, it can now be negative. So the cube root of 1 is 1. The cube root of -1 is -1. The cube root of 8 is +2. And the cube root of -8 is -2. So what do you see if it's symmetric about the origin? And this one here is 1, 1. This point here is -1, -1.
Yes, that X and Y values are the same number but different signs.
Different signs, yes. If the X and Y values I'm going to say keep their same values, but have different signs. So it's either going to be first, third quadrant, or second and fourth quadrant. Same thing here. This is -1 equals 1. This is -8 equals 2. 1 at -1, 8 at -2. Two. So 8 goes from negative to positive, positive to negative. Or I can go from negative to positive, negative to positive. But they keep the same values. They just change signs. If you think about it, if it's flipped across the origin, it's flipped across the x-axis and then across the y-axis. If I took this graph and flipped it over, it's over here. And then if I flip it over again, it's over here. So if it's across the origin, it's across both the x and the y-axis. This is an odd function. So mathematically, how can we distinguish if it's an odd function or an even function? An odd function if you place a positive x value and a negative x value, same number, into an equation, and the y values are the same numbers, but different signs. So here's an example. If I plugged in 2 here or -2, it's the same number, but different signs. Not 2, I'm put 8. I'm sorry, 8, make it 8. So the cube root of 8 is +2. The cube root of -8 is -2. So I plugged in the same numbers, positive and negative, and I got positive, negative, the same answer. That's how you tell it's an odd function. right, let's look at this. Example. Tell me if it's odd, even, or neither. Okay, so let's do the first one. So how do we determine if it's odd or even? Or neither? Plug in the positive, negative of a number. If the answer are the same, then even. If the answers are the same, but different signs, then odd. Else, neither. Oh, let's look at the first one. Pick any number. Don't pick any big one. So pick something small and easy. Not 0. Let's just try 2. 2's easy to do. 2, 4, 6, 8. Plus 3. If you look at these, we're gonna get the bigger numbers. So let's pick 2. We're gonna use positive 2 and negative 2 for all of these. So let's see. If we have positive 2 in there, 2 squared plus 2. If we have negative 2 in there, we have negative 2 squared plus 2. So negative 2, or 2 squared is what? 4 plus 2? 6. Negative 2 squared. Yeah, negative 2 times negative 2 is positive 4 plus 2, 6. So is it odd, even, or neither? Very good. Do the next one. Same thing. F of 2 and f of negative 2. What is 2 cubed?
No, 8 yet.
Which one? 8, because 2 times 2 is 4, times 2 is 8. 8 plus 2? 10. Because this is 8 plus 2. Negative 2 cubed. Cubed. Negative 2 times negative 2 times negative 2. This is negative 8 plus 2. The signs are different. Take the sign of the larger. 8 minus 2 is 6. So this one's 10. This was never negative 6. So it's neither. Because in order to be odd or even, they have to have the same answers, just different signs or same signs. F of 2, f of negative 2. Two cubed is 2 squared. 8 plus 4. Negative 2 cubed. Negative 8. Negative 2 squared. Negative 8 plus 4. Since 8's bigger, its answer is negative. 8 minus 4 is 4. Negative 4. This is neither. Uh, 2 to the 5th. 2 to the 3rd. 2 plus 3. Negative 2 to the 5th. Negative 2 cubed. Negative 2 plus 3. Two to the 5th. 32. There's 2 times 2 is 4, times 2 is 8, times 2 is 16, times 32. 2 to the 3rd. 2 plus 3. So 32 plus 8. 40 plus 2 plus 3. 45. Very good. Negative 2 to the 5th. Negative 32. Negative 2 cubed. Plus the negative 2 is negative 2 plus 3. Negative 32 minus 8. Negative 40. They're both the same sign, so it's negative. Add the numbers. Negative 40 minus 2 plus 3. They're not the same. Neither. Okay, same thing here. F of 2, F of negative 2. Two to the fourth, 2 squared, plus 3. Negative 2 to the fourth, negative 2 squared, plus 3. What's 2 to the fourth? 2 squared. 16 plus 4, plus 3. Negative 2 to the fourth. Positive 16, good. Negative 2 squared. 16 plus 4, plus 3. So what is that one? Even. Very good. Go 2 to the fifth. 2 cubed. 32 plus 8, plus 2. Negative 2 to the fifth. Negative 2 cubed. And negative 2. So negative 32 minus 8 minus 2, negative 42. So what is that? That's odd. How about this one? Do it the same way. If I put 2 in place of x, what do I get as an answer? Three. If I put negative 2 in x, it's a constant. Yeah, it stays 3. So is it odd or even or neither? Yes, this seemed like a long, arduous process, but I did it for a reason. Looking at these 7 examples, what can you come up with as a conclusion? Let's look at the ones that were even, the ones that were odd, and the ones that were neither. So first off, we know that constant terms are even. Right? So odd functions cannot have constants in there at all because they're even. Even functions can have a constant in there. So that's the first thing you notice. If a function has an even constant in there, it's either going to be neither or even. Because it has a constant in it, but it's a neither. Why is this one a neither and this one an even? Exponents of exactly. What do you notice about these exponents versus these exponents? Yes. If you have only odd exponents, because this exponent is actually a 1. If you have only odd exponents, like this one here, 5, 3, and 1, they're all odd, it's an odd function. If you have only even exponents that are, let me see where they're. I don't have that. No. If you have an even exponents or a constant, it's even. Any combination of odd and a constant, neither. Odd, even, neither. Odd, constant, neither. Even, constant is even. So look at those, and now it doesn't matter what I give you, just look at the exponents. If the exponents are all even, it's an even function. If they're all odd, it's an odd function. If there's an even number in there, it cannot be odd. It can only be even at best if everything's even. So that takes care of that section. That's all there is to it. Pretty easy. I was thinking, should we start the next section now? Because we only have, what, 30 minutes left? Well, let's do it. Chapter 2, Section 5. Transformations. Transformation is just another way of saying shifts. And that's right, that's the sheet I gave you on the back of the first sheet, transformation rules. There are actually 5 rules, 5 shifts possible. There's a horizontal shift. There's a vertical shift. There's a reflection. There's a horizontal shrink or expansion. And then there's the vertical shrink or expansion. They say shrink or stretch. Stretch. The horizontal one, think of an accordion. You either push it in, it gets smaller, push it out, pull it out, it gets wide. That's expansion. That's a stretch. The vertical is like you're stepping on something. Like a Coke can. You have a Coke can, you step on it, you just shrunk it. Don't know what you would expand, but like a rubber band. The first 3 are super easy. We deal with functions. A function looks like this. A horizontal shift. No, that's either left or right. occurs when x inside the equation is either added to or subtracted by a number. Remember when we talked about equations of circles? And I gave you where is the center of this circle? -3, 5. Because originally the center's at the origin. It's at 0, 0. If I move it to x plus 3, what does x have to be to push it back to the origin? -3. And same thing as y. If y minus 5, what does y have to be put it back at 0? 5. So it's always the opposite of what's inside the parentheses. If I gave you x minus 7, it'd be 7. The same thing happens here for the horizontal shift. It's the opposite of what's inside the equation. Because what we did here is we took x plus 3 and set it equal to 0. We took y minus 5 and set it equal to 0. These are our new centers. -3, 5. So we do the same thing here. If I gave you a function that looked like this, how would you graph it? Where is the shift going? It's going to -4. So we'd first have to graph the function. What does that function look like? It's the parabola. Again, this is what I told you. The sooner you memorize all those tables, the charts, it makes it easier for you. X squared is a parabola. Because we have an x plus 4, that means our graph shifts to -4. Basically, what that means is there's my new origin. That's my new origin. When you do transformations, you're shifting the origin from the center to some other new place. So horizontal shifts occur inside the parentheses. Order of operations says you're supposed to do inside the parentheses first. So the first thing you're going to do is a horizontal shift. That's straightforward. The second shift we do is a vertical shift. This one's up and down. This one occurs outside the function. It's a constant. If I had this function, there's the function, there's the x. This is outside, has nothing to do with x. So this is a vertical shift. I'd first graph the function that's being talked about is x squared, that's a parabola. Since there's no horizontal shift, I now look at outside the function. What this thing says, since it's positive, I go up 2 spaces. So I take from my origin used to be here at 0, 0. It's now here at this new origin. That's my graph. Up if positive, down if negative. Reflections. Or flip. Occur inside, outside, or both. The parentheses. So for example, let's say I had, well, negative x squared. Since it's outside the operation, outside the function is x squared, and x doesn't have a parenthesis, so it's if it's outside, the function, flip across the x-axis. So we know the function is x squared. The negative happened outside the function, so it says all my answers are negative, so it goes down. Okay, how about inside a function? If it's outside, flip about the x-axis. If it's inside, flip about the y-axis. So with this one, we know our original function is a square root of x. The square root of x looks like this because we cannot have any negatives inside there. If I change the sign of x inside the function, since I cannot have a negative inside there, x has to be negative. And now change the direction it's pointing. Again, so if it's inside, I flip across the y-axis. If it's outside, I flip across the x-axis. And if I have both inside and outside, then it's x-axis, then y-axis. That's a reflection. Horizontal shrink or stretch. So here's our function. If I have a coefficient in front of my x, and it's positive, it's greater than 1. If it's 1, it doesn't matter, it doesn't do anything. But if it's a integer or a number bigger than 1, it changes the shape of my curve. For example, let me see. If f of x equals 2x squared, what do you think that's going to do? Just the opposite. What's going to happen, because our original parabola was x squared. Now what I'm doing is I multiply the x by 2 before I square it. So when this x used to be 2 and then it equaled 4, if I put 2 inside there, it equals 4. But now I take 2 and I double it. So I have 4 and I square it. So at 2, it's now at 16. So it makes it skinnier. It grows much faster. We call this the shrink. Makes it skinnier. That's if our coefficient is greater than 1. What if we had a fraction or a decimal in front of the x? It makes it wider. So with this one, what if we had f of x equals 1/2 x squared. Normally, when x is 1, y is 1. But when I plug in 1 in here, I now get 1/2. So it becomes 1/4. So it grows much wider. It used to be here, now it's down here. So the graph would grow much wider. So if you have a coefficient, a fraction in front of your x, it makes it wider. If you have an integer, it makes it skinnier. So far, so good. So that's happening inside the parenthesis. Horizontal, remember, all horizontals happen inside the parenthesis. The horizontal shift happened when we add or subtract to x inside the parentheses, inside the function. A horizontal shrink or stretch happens if it's inside the parentheses to x. Before we do anything to it, we change x. So the last one we do is the vertical shrink or stretch. We have what this one looks like is if we change outside the function. Unlike a vertical shift, this is you multiply is a coefficient in front of your function. It's multiplied to it or divided to it. So we have the first one if a is bigger than 1. Let's see what happens here. So as we had our function f of x equals 3x squared. The way we graph this is you always start off with the original function. In our case, it's x squared. But what I'm doing here is after I get my value for x squared, I triple it. So what's that going to do to the graph? Vertically, yeah, it's going to stretch it out. It's just like one of those, I don't know if you guys remember those bendable buddies. You could take them and stretch them out. You get really skinny. That's what's happening here. This is the same as a horizontal shrink. But we're pulling the numbers out even further. That's if it's a integer. If the coefficient is a fraction, this is a vertical stretch. This is a vertical shrink. So what's going to happen here again, it's happening outside the function. It doesn't affect x because x, you have to do order of operations. You have to do the square first and then divide by 2. So what that's going to do it's gonna shrink it. It's gonna push it down, make it fatter. So the horizontal stress pulls up. And this just pushes down. So your point xy from your original function on this first part now becomes x ay. That's what happens to your points. That's how they change. And this one, your original point xy now becomes x by, or b's a fraction. In other words, if you have a vertical, if you have a coefficient in front of your function, then all you're doing is really multiplying that coefficient to the y values. X value is going to be the same, and then the y values change. Unlike the horizontal, this is the horizontal shrink, and this other one is the horizontal stretch. So if you have an integer, you have a horizontal shrink. They get skinnier. If you have a fraction inside affecting your x, then it gets wider. So your point xy, and if it's inside and it's an integer, your point changes to that. Your points change from xy to x divided by, because you have to make your x's smaller. And this one just does the same thing. It says this one changes your point xy to x over b y. Yeah, you just have to play with those. But this is, you have this on here, you have your template, and just play around with it. And that's all there is for that chapter. I was going to give you some example problems, but I figured cramming so much at one time, I want you to just explore it slowly. And if you have any questions, just holler. Online, I have the homework problem sets also worked out, so you could, and each homework problem I worked out, I explained what's going on. So it's got its own little mini lectures in it. All right. So that does it for today. We finished chapter 2. Next week we'll do chapter 3. Well, half of chapter 3. I'm gonna try to slow down from here because now we're getting into the more complex stuff. Chapter 4 is gonna be the most difficult one, but then once we finish that, chapter 5 gets a little bit easier, and chapter 6 we'll finish that in one day also. All right, everybody. Have a great, safe week. And